My name is Sandeep Kumar, CSCC section. My project is about base tree and code tree. What are the definitions and applications and what is the conditions of tree and code tree networks? First of all, we define definition about tree definition. A tree of electrical network is a set of branches which is a set of branches which contains all the nodes of the network but does not form any closed loop. It is similar to what a network hopefully is a communications network. We can see below diagram of a tree of electroid networks as defined as above. We are the four diagram we can see and one, two, three, four. This is the tree of electric network diagram and this first to second battery and second to four third is the current and third to fourth is the plus or minus battery and middle of one is 5 is the extension. And now if we remove the branches of 1 2 3 3 4 and 4 on from the circle, we will get the graph as shown in below in figure 2. Figure 2 is the diagram of the above graph. In the figure 2 comes all the five nodes of the network but does not from any closed loop path. This is the example of tree electric network and we can see the first two three four in figure 2 there is a 1 voltage 3 resistance and now we can try see about in this way such as tree can be formed in a single circuit which contains same five nodes without containing any closure loops. We can see figure 3 1 2 3 4 5. 1 to 4 is the current and 4th to 5th is the resistance and 5th to 2nd is the resistance and 2nd to 3rd is the current. And we can see diagram figure 4 and the points are 1 2 3 4 5 and 1 to 2nd is the current voltage and 2nd to 5th resistance and 5th to 3rd voltage and the branches of a tree are known also as winds. In figure 2 and figure 3 and figure 4 we can see that there are four wings or branches of tree in which and tree of that electric network the number of nodes in the network is 5. So in this case 4 is equal to 5 minus 1 and number of wings is equal to number of node minus 1 and this is the general equation for trees and electric networks. The general equation and normally written as L is equal to n minus 1 and where L is the number of branches in tree and n is the number of nodes in the networks from which the trees are formed. And this is the code tree and networks and definitions and tree of definitions and let us I'm trying to explain code tree of network connection. When a graph is formed from an electric network, some selective branches are taken. The branches of the network which are not in tree formation are referred as a links or chords. The graph formed by these links and we can see about it is figure 5 1 2 3 4. This is the fifth is the junction and 1 2 3 4 is the points and network are connected with each another and figure 6 and figure 7 the quotes are shown in the above figures by red colors and is found from figure 5 figure 6 and figure 7. That's the sum of the numbers of branches of tree and its core tree is the total number of branches of electric networks. So number of linkages core tree is 1, then L is L plus L dash is equal to B, where 1 is the number of strings in the tree and B is the number of branches in a network. So, and L dash is equal to B minus L, and L dash is equal to B minus into N minus 1. L dash is equal to B minus N1. We can see L is equal to N minus 1, and tree all same procedure is as shown in code tree also there, and where n is the number of nodes in the electric networks, and this is the procedure. We can apply number of branches and means we divided. Properties of tree electrical networks. A tree consists of all the nodes of the electric networks, and a tree has the number of branches which is less than one of number of nodes of the tree networks. And quote, a tree must not have any closed path in these many branches and possible trees in same electric networks. And the sum of the number of branches in the tree and number of branches of the core is equal to the total number of branches then electric networks. The number of independent Kirchhoff voltage law equations can be formed from an electric. The number of independent Kirchhoff law voltage can be formed for an electric network is equal to its number of links or code of tree. So number of KVL equations L dash is equal to B minus N plus 1. This is the equation of KVL equation, and other point is the number of independent Kirchhoff current law equation can be formed for an electric network is equal to its voltage of wings. So number of KCL equations is equal to L is equal to N minus 1, and we can see above above point Kirchhoff voltage law. There is a difference between Kirchhoff current law and Kirchhoff voltage law equations. L dash is equal to B minus N plus 1, and KCL equations L is equal to N minus 1. This is the difference in tree and core tree, and different Kirchhoff voltage law equations and Kirchhoff current law. Also, one more time I am explaining properties of tree of electric networks, and Uh, a tree consists of all the nodes electric networks. A tree has a number of branches which is less than one of number of nodes of the electrical networks. And tree must not have any closed path in any part of it. And there may be many different possibilities in same electrical networks, and some of the numbers of branches in a tree and core tree are equal to the total number of branches in the networks. And these are the equations, and you can see diagrams. Red color marks is the between black color lines, and tree and equations, and this is the properties of tree electrical networks. And above equation as for this is the tree and core tree equations of the mankind. This is the voltage of the, and thank you.